Good morning, my plant-loving friends. Welcome to your Daily Plant Pulse, a podcast-styled series rooted in my deep fascination with plants. Here, plants go through a plant pulse research protocol where we uncover fascinating insights from scientific studies and share them with you. All studies I review are sourced in the description. I'm not a doctor, just someone who loves to research plants and present what I find. Our 9-part series takes you from an introduction to the plant through amazing studies and even an occasional bonus episode. Be sure to check out our Plant Pulse playlist where all of our episodes on all plants will be. And when a plant profile review is complete, explore our Living Library playlist for an in-depth consolidated review. We dig deep into history, forgotten studies, and untold stories so plants can have a voice and their story can be told. Welcome to episode 10, a special bonus episode where we explore the suppressed side of the plant world. Every so often, a plant's story leads us beyond biology and into the realm of history, economics, and influence, where past discoveries met suppression and curiosity collides with control. In these rare episodes, we follow the trails that don't always make the headlines. Patents, policy shifts, conveniently forgotten studies, and stories that quietly vanished from the public's eye. We're not here to speculate, but to observe what's been left unsaid and bring into the light. The truth speaks when it's given the light. Sometimes understanding a plant means understanding the world that silenced it. So let's get deeper into the yam story. This is one of the most overlooked breakthroughs in plant chemistry and the story of how it was nearly buried. There's a molecule inside wild yams that we've been discussing that could change everything. It's called diosgenin. You've probably never heard of it if you haven't heard my series, but we've definitely been talking about it. Yet it's on the forefront of cheap hormonal treatments we've all heard of. And while it's been used to create life-changing medicines, most people have never heard of its capabilities discovered in the 50s. Why? Because it's locked away. Public studies never funded. And just like that, the key was buried decades ago. Let's dig into the history of yams a bit. In the 1940s, a renegade chemist named Russell E. Marker cracked a code that would reshape hormone science forever. Marker discovered how to extract diosgenin, a powerful plant sterol, from wild Mexican yams. His goal was simple: convert it into progesterone. But what he uncovered went far beyond hormone synthesis. Marker's process was revolutionary. It produced 20 times more hormone than traditional animal extraction. That meant no more pig ovaries, cow glands, no horse urine, just plants. It was clean, it was cheap, and it was humane. And quietly, this compound also threatened a billion-dollar industry. To make it happen, Marker trekked deep into the jungles of Veracruz, Mexico, searching for the perfect yam. He found Dioscorea mexicana. He refined his process and funded Syntex SA with 2 investors, Eric Somlo and Federico Lemon. Within months, Syntex became a global steroid powerhouse, but Marker made one fatal mistake. He trusted the wrong people. He refused to patent his process of diosgenin extraction. He believed science should save humanity and not be for profit and not be locked away from other people. Solomon had other plans, though. Described by Marker as ruthless, Solomon pushed for control, patents, and profit. Marker walked away within months. He left the lab behind, the process of all commercial rights behind. He never worked in chemistry again. Instead, he restored antique clocks the rest of his life. So the man who unlocked the compound walked away from the industry it could have transformed. And the compound, it stayed locked for the majority of us. Diosgenin isn't just a stepping stone to progesterone. It's a bioactive compound with serious potential. So much potential that they have shown little studies in humans. Studies in rodents have shown diosgenin can reduce tumors, it supports liver health, it enhances cognition, it reduces inflammation, it helps asthma, it even assists with erectile dysfunction. This is not fringe science, it's documented, studied, and promising. But here's the problem. Its raw form, diosgenin, is mostly locked inside saponin glycosides. Your body can't use it directly. It's there, but it's inaccessible. Unlocking it requires chemistry, not the kind of chemistry that needs $1 million lab, but basic hydrolysis, either enzymatic or acidic, can release its power. This isn't futuristic, it's basic chemistry a high school lab could replicate, if only it were legal to have the compounds to unlock this molecule. And yet most supplements don't unlock it. They powder the yam, they package it, but they don't make diosgenin available. So the bioavailability remains basically nothing. So the compound stays locked and the benefits stay out of reach. And many people are left purchasing supplements that do not benefit them at all. It's almost as if someone doesn't want you to access this compound. The plants are everywhere, but the compound is locked away, and the tools to unlock it, they've restricted. So where does diosgenin come from? 2 species carry the most, Dioscorea alata and Dioscorea bulbifera. Dioscorea bulbifera is especially rich. Its areobulbs, most of those little growths that form above ground, are packed with saponins. Traditionally, it's been used to treat inflammation, tumors, and hormonal imbalances. It grows aggressively, spreads fast, thrives in poor soil. It's invasive, it's prolific, and it's chemically potent. Dioscorea alata is vibrant, fast-growing. It's cultivated across Asia, Africa, and the Caribbean. Its steroidal saponins support fertility, liver function, and hormone balance. It even shows significant promise against cancer. Both species are easy to grow. They're chemically rich. They reproduce through aerial bulbs, making them hard to control, but incredibly resilient. And yet, despite their abundance, their full potential remains largely untapped. These plants are not rare. They're not exotic. They're not hard to find. But the compound they carry, that's another story. This is just the beginning. In the next episode, we'll dive deeper into the story of yams and their forbidden compound, diosgenin, and we'll ask the big question: what happens when nature's pharmacy becomes too powerful to allow? Stay tuned for part 2. The Pulse continues.